Okay, in segment 2, we're going to get a little bit more involved in all the knobs and buttons on this recording console, what they're called, what they're for, more importantly, how you could use them to shape your music sonically the way you want to hear it. Of course, all these knobs and buttons live inside the software that you've purchased for your home computer, if that's what you have at home. We're also going to talk about signal processing. Now, signal processing is the way that we further shape a sound. We may add a dimension to it. When you open up some of the programs in your software, you may see words like delays, reverbs, flanging, chorusing. You may see other words like compression, gates, or expanders. Well, we're going to talk about what all that means, what they're used for, and more importantly, an easy application-based way that you could use them to, again, sonically shape your music the way you want to hear it. So welcome to segment 2, Real Application Training. Okay, so we're getting ready to dive into the world of recording engineering. I encourage you to keep in mind it takes real recording engineers many, many years and many education hours to really understand and learn and comprehend everything I'm about to talk about today. We're going to keep it simple, and we're going to be in general in a sense, but I also want to encourage you to watch this DVD several times. Use your workbook certainly to write down information that you feel is pertinent to you, and it's going to take a little bit of time for this to really, get absorbed and this to get ingrained in how you proceed in your home recording studio. So if everything is not comprehensible to you the very first time we go through it, keep in mind it usually is not for everybody. But as we move forward and you view this several times, if you choose later to go into the online programs that are going to spend a lot more time and detail in discussing these items, it's going to be, a lot more digestible for you. But for right now, we're just going to do a basic overview of all these knobs and buttons. Now, some of these won't be in your home recording software, but chances are most of them will. The first thing we're going to do is discuss the input channel. Earlier in our segment 1, I talked about a split console design, and I talked about an input channel or strip, and then I talked about a monitor channel or strip. So initially I'm going to talk about an input monitor strip, and this strip would be used if I was going to record an instrument. In a little while I'm going to demonstrate recording a guitar amplifier being mic'd up by a Shure SM57 microphone. So the microphone is plugged into this channel strip. I'm going to begin with the very top section here that's called the input section. You'll see a button that says line and a button that says mic. Well, this is essentially an amplifier for the microphone. It's called a mic preamplifier. And this is an amplifier for the line amp. The line amp would be something that would be used to, let's say you had a keyboard, you plugged in a keyboard. We're referring to a line level signal. In most cases in your home studio, plugging a microphone, you use the mic preamp. In some cases you may use the line amp. We're going to talk about direct injection boxes, DI boxes, later on. DI boxes are used to take a guitar or a keyboard and then use it to plug into a mic input. But if you don't have one of those, you may take a 1/4-inch jack off of your keyboard and plug it into the line input. That would be the appropriate way to patch it. So I have the line amplifier and the mic amplifier. I have a button here that says flip. Well, flip is a button that really says I'm either going to be in the microphone or I'm going to be in the line. So on your mixer, wherever it may be, whether it's a smaller mixer at home or in your computer, you'll certainly have a mic line switch function where you'll be able to determine if you want to use the microphone preamp or the line amp. Right now I'm going to use the microphone preamp, as I see the light indicator is next to the mic preamp. At that point I'm going to use this to get the microphone signal up to a 0 level. Now a 0 level on this board represents what we call unity gain. You want to have sort of a 0 level operating level of your information as it goes through the electronics of a recording console. And in your computer you'll have a predetermined 0 level, and sometimes it's -12 or -15 as it were in the digital domain. So you want to have a unity gain level. So what we want to do, as the guitar would be playing, I would use this mic preamp to then get the guitar level up to around 0. That would be my optimum level. We'll do that in a little while. For the time being, I'm going to bypass this section right under it. It's called DYNAMICS, ICS, dynamic section. The dynamic section is really an additional component of this particular console, which is extremely elaborate. And it consists of a compressor and a gate right on the channel itself, which is usually not the case, but it is on this particular console. We're going to get back to that just a little bit later. Let's go down a little further, and these next set of instruments here are called the filters. Now, filters are very important. We see one here that has an elbow that sort of goes down and then comes back up. And we see another one that has an elbow that sort of flat lines and comes back down, like you can see in your workbook. Well, the first one I described is called a high-pass filter. And as you can see, the elbow goes down in the beginning and then flattens out as you move forward. That means the high-pass filter allows high-frequency information to pass and filters out low information. The low-pass filter allows low information to pass and filters out high information. Now, where would I actually use this? Let's say I was recording a hi-hat or a cymbal on a drum set. I'd be very likely to use a high-pass filter. What that means is I'm going to cut the frequencies of the lower frequencies and just let the high frequencies through. What this allows me to do is sort of isolate the cymbal sounds and separate the bass drum or some of the other drum sounds that may get into that microphone, and I'm essentially going to take them out of the signal path. So I'm going to actually eliminate the low frequency. On the high-pass filter, on the low-pass filter, I'm going to let the low information pass through and I'm going to filter out the high information. Conversely, on a drum set, if I was recording a bass drum or some of the tom-toms and I was getting some cymbals coming through those mics, I may put a low-pass filter on that particular microphone, allowing the drum to come through the lower frequency, the bass tones, and then eliminating the higher frequency from the cymbals. What I would do this for is to provide some difference in the microphone getting the cymbal and the microphone getting the tom-tom or the bass drum. It really helps in distinguishing the different sounds of the different drums and their respective microphones. So this is something you use especially when you're recording drums or some other instruments, but anytime you're hearing too much low frequency coming into that microphone, sometimes a microphone has a filter on it itself, but in this case you would also have it on the channel strip. So again, high-pass filter takes low frequency information and eliminates it, just like the diagram suggests. And low-pass filter takes high frequency information and eliminates it and lets the low frequency pass, just like you see in your workbook. So you may want to make a few notes about that and sort of determine when you feel you would likely use a high-pass filter or a low-pass filter. As we move down, we see a lot of knobs and buttons here on this particular channel strip, and there's a lot of sort of symbols on these knobs and buttons. Now, we're going to take them one at a time. Basically, what these are very sophisticated treble, bass, and mid-range controls, if you will. It's called an equalizer, and what an equalizer does, it gets very specific behind shaping the sound with respect to the bass, the mid-range, and the high end. So if I'm going to want to reshape the sound I'm hearing in the microphone and maybe accentuate some low end, some mid-range, or some high end, I would use these features here. Now, each equalizer has a sort of different way of labeling it, but usually there'll be a low, medium, high. It'll be an order of low, medium, high, and then it'll have different ways of labeling what that is. Now, in this case, I have low frequency assignment. I could select whatever frequency I want to cut or boost, and I could accentuate that frequency or I could decrease it. Such is the case with the low mids, the high mids, and the high frequencies. There really aren't any rules here. Really, if you've done your job right with your reference mixes, you've got speakers that you sort of know how they sound, you're actually going to be able to use the equalizer to get that sound in your studio the way you'd want to hear it. Now, when we're configuring sound on this section here, keep in mind this is the input channel. So this is the channel inputting the sound to the recording medium. So if I do manipulation on the sound, that's the way it's going to get recorded and it'll forever stay that way. I can't undo it once I do it here on the input channel. So as we move down, we see another set of buttons here, and these are called the auxiliary send. Sometimes they're referred to as cues, but essentially what an auxiliary send is, it is taking the signal and essentially splitting it into another direction. And then you have a volume control that determines how much of that signal you split in another direction. So I typically liken it to a car going down a highway. If we looked at the microphone signal as a car, it came in the mic pre, we may have provided some filtering on the signal to get rid of some high frequency information or some low frequency information. We may have then further defined some bass, mid-range, or treble frequency information by either adding some or taking some away. Then we come to this auxiliary send section, and we could take that car and we could actually split it into two cars. It's identical, but we're actually now taking the car, continuing down one path, and then we're allowing it to split apart and go down another path. This is a very specific use, which we'll get to later. Suffice it to say, at this point, though, that's what the auxiliary sends are for. It's an opportunity to send that signal to another location. As we move further down here, we see we have a fader here and a fader here. These are volume controls. We're going to disregard this one because, as I stated earlier, this particular recording console is designed in an inline fashion. But today we're going to use it in a split type of operation where we use one channel for input to the recording medium and one channel to receive the information back and actually hear it. So finally, we have our final volume control here. Well, this volume control is going to determine how much of this signal leaves this channel. I'm going to actually keep it at 0, as all things want to stay at 0, and then I would appropriate the microphone preamp to bring the signal up to 0, which we'll see we'll do in a little while. And finally, I have to determine how this signal is getting out of the channel and going to the recording medium. Now, we have the opportunity to record multi-tracks in our multi-track format, meaning there may be 24, 48, 96 separate tracks, separate components of information that we could record and then play back simultaneously at the same time. So I'm going to determine which one of those tracks. Now, in the analog domain, we have what's called a busing network, and what that really means is an opportunity to say which track you want that information to go to. So I may depress a button 1 here, and at that point it's going to track 1 on Pro Tools or on whatever hard drive recording medium I may be using. So let's quickly recap the input channel. The microphone comes into the input section. It is a microphone, so I select mic input. I've decided in this case I was going to put some filtering on the bottom and some filtering on the top. So I would filter out some of the very low frequencies and also filter out some of the very high frequencies. So I would have a high-pass filter and a low-pass filter applied, both, to kind of take some of that really high-end information, really trebly stuff out, and really low, boomy stuff out. And then I'd further equalize it, of course, by hearing the sound. This is something you want to do as you're hearing the sound. And then I'd come down to my auxiliary section. I've selected to not use that at this point. I just want the signal to travel down that one road. I want it to go through my volume control here, and I want it to exit the input channel to go to track 1 on Pro Tools. And that essentially is an overview of the input channel, and in a little while we'll demonstrate by recording a guitar through that channel. Okay, well, as I said earlier, you may want to review that segment again, but keep in mind we're going to go over this a few more times as we move forward also. So, we've got our input channel we've assigned to track 1 on Pro Tools. Now we're going to take Pro Tools track 1 and we're going to return it here on this channel just for demonstration purpose. Chances are likely it would automatically return to channel 1, but we're going to return it here just for demonstration. And I'll look up here and I'll see that it's assigned to microphone input because the red light there is indicating the mic. So I'm actually going to flip it here and put it on line input. In this particular console, though, it's normal to what we call a tape input. But in your console at home or in your computer, you may have to assign it to get the tape playback or the playback of your Pro Tools hard drive. Okay? So for the time being, though, we're here on line input. Again, we're going to bypass this dynamic section. We're actually going to talk about that a little bit later. And we're going to get to our filtering section. Now, the filtering section also applies in this monitor